Now that you have an understanding of filling in the molar masses and the balanced molar masses, I'm going to give you an example of how to do some calculations with this information. I'm using the equation for the reaction that I did in the previous homework, iron nitrate reacting with sodium hydroxide to produce ferric hydroxide and sodium nitrate. And you can see that I have calculated the molar masses here and the balanced molar masses, and that my total masses are equal to each other. So I have done the correct molar masses and the correct balancing, and this is a nice check to see that everything there is correct. The balanced molar masses can be used as a recipe, and I'm going to call the balanced molar masses here the original recipe, so to speak. So everything that's in here is the, quote, original recipe. And in my original recipe, if I react 242 grams of ferric nitrate with 120 grams of sodium hydroxide, I will produce 107 grams of ferric hydroxide and 255 grams of sodium nitrate. That's the original recipe. And that works because the molar masses are based on the weight of each atom, and all the atoms that I put in over here have to end up over here, and thus I can use the weights as a starting point for doing more calculations. Let's look at a question. How many grams of sodium hydroxide are needed to fully react 2.6 grams of ferric nitrate? What the question is asking you to do is to take the original recipe and scale it down. Just like you would do a recipe of cooking and you only wanted to make half the amount, you would scale all your ingredients down by half. In this case, we're not doing it in half, we're doing it to 2.6 grams. So we need to find a ratio of our two starting materials to each other and apply that ratio to the number that we are looking for. And we can do this with a proportion. The first step is to write the original recipe on the left side of your proportion. I'm going to start with sodium hydroxide, 120 grams. This is where it's really important that you label with the type of salt that it is, and that you're also using the balanced molar mass amount. 120 grams of sodium hydroxide requires 242 grams of iron nitrate. That is the recipe. How many grams of sodium hydroxide are needed if I want to use 2.6 grams of ferric nitrate? And this sets up my proportion. I'm looking at a ratio between these two numbers and applying it here to find x. So if I do the math out, you cross multiply. So multiply 120 by 2.6 and 240 by x and solve for x. So in this case, I've made it easy for myself. I'm going to multiply 2.6 onto each side. And that's my trick. I like to put x here, so it makes my math a little easier. Multiply by 2.6 grams of iron nitrate. Remember, things cancel on top or bottom, so that's gone. And my grams of ferric nitrate will cancel with my grams of ferric nitrate there. And if I do my math, I'll end up with 1.29 grams of sodium hydroxide are needed to completely react 2.6 grams of ferric nitrate. I would expect this number to be less than 2.6 because in my balanced molar masses, the mass of sodium hydroxide is less than ferric nitrate. Okay, let's do one more. How many grams of precipitate, the precipitate is the solid, are produced from 0.65 grams of sodium hydroxide? So now the question is saying, if I start with an amount over here, how much do I get over here? And this is where we start getting into limiting reactants and excessive reactants. So I'm saying if I want my production of ferric nitrate to only be based upon the amount of sodium hydroxide I put in, how much is that? So I'm going to set up my proportion again with the original on the left side. Oftentimes the hardest part of these problems is just figuring out what is to be used. So here it's the precipitate, which is ferric hydroxide, and sodium hydroxide. Those are the two numbers that you get from the original recipe. So my ferric hydroxide number is 107. 107 grams of ferric hydroxide is produced from 120 grams of sodium hydroxide. How many grams of ferric hydroxide are produced from 0.65 grams of sodium hydroxide. You can see that when I write my proportion, I can put the question in there, and then it makes a little more sense. So now I need to cross multiply and divide, or if you've set it up in a clever way, you can multiply 0.65 grams of sodium hydroxide, and they cancel. And you do that on both sides. This is basic math algebra. Extend the line. My grams of sodium hydroxide cancel. This is why it's important to label what it is, so you're canceling the correct things. The label all comes together. And then if I do my math, I'll end up with 0.58 grams of ferric hydroxide are produced from 0.65 grams of sodium hydroxide. And if we go back here, I expect something a little bit smaller because my ferric hydroxide mass in the balanced chemical equation is less than my mass of sodium hydroxide. 107 versus 120, 0.58 versus 0.65, pretty comparable. All right, finish step 5 and then do the practice problem and see how far you get.